So we're thinking of discussing routing basics today. So which is mainly we'll try not to get much into the protocols themselves, into routing protocols, but just routing generally, uh, to just discuss our foundation regarding routing. And then the format we're going to take is like the normal format, is like a discussion sort of. Like we discuss about different things and we'll give our thoughts and ideas and help each other to learn. So routing, where do we start from? Um, so um, what's like your understanding of routing? So if someone comes to you and says, what does it mean when you say you're routing something? Or if you have a router, what's the purpose behind the router? What does the router do? What will be your explanation of that? Does anyone want to go first? So, Aonika, you want to go first? Someone gives you
Thank
someone.
you. First of all,
Yeah.
I have to say that I'm happy that I was accepted to participate. I'm among you all. I'm probably the guy who has the lowest experience. I'm not involved directly in work with routers, but I am eager to participate and learn from all of you. So if you accept
No,
me,
absolutely okay, man. Oh no, absolutely okay,
I
Aonika.
will
Absolutely
participate.
okay.
My understanding of routers is
Yeah.
that they are devices connecting networks.
Yeah.
And like you said in your first hangout,
Mhm,
every port on a router
mhm,
is a way out
mhm.
or a way in for a network, right?
Yeah.
Unlike ports on a switch,
Mhm. Yeah. So let me tell you.
where ports connect devices, not networks, right?
Yeah. Yeah. Okay.
So in short, this is my take on your question.
So let me put that down. So, uh, what is the purpose of a router? And so Aonika says it's to connect networks. So any other thoughts out there? So, Michael, what do you think? So what like the whole routing itself, what does it mean when you say, well, something is being routed? What does it mean by something is being routed? Michael, still there? Hello, Michael. I think maybe we've lost Michael. Yeah, we lost him. Yeah, he joined again. Yeah, Pamani, what about you? What's like your thoughts behind routing or a router?
Basically, as far as my brain captured, the routing itself is uh, joining networks, like what the first caller said, joining networks
Joining
and
network.
sharing information from one network to another uh, through a router. So it would be routed from one network to the other. Uh, yeah.
Another. Okay. Yeah. What about our expert? Um, Frank.
The main purpose of a router is to find the best path between the networks.
Nice one. Nearly for to find the best part between networks.
Yeah.
Which is, I mean, to me, like, I'll echo what Ferenc said also. So to find the best part between networks. A router is simply, to me, to put it simply, I'll say a router just simply means, or the basic purpose behind it is to move packets from one network to another, in an effective way. So the next question will be, how does the router achieve this purpose? So how does it do this? So if a router, if its job is to move a packet from one network to another network and to do it effectively, what exactly does a router use to achieve this purpose? how does it achieve this purpose? Ferenc, what do you think? How does it achieve this purpose?
Routing protocol.
Routing protocol, yeah, that's one of it. So let's put all that down. So let's go routing protocol. So how does a router achieve this purpose?
So I mean, either static or dynamic routing protocol.
Yeah, I get what you're talking about. There's something in particular that I was looking looking for in terms of that. That how does it achieve this purpose? So if I go, let me go copy image. Let's put it there. So we have a router here. So this router, it go over here. It's connected to one network here. It's connected to one network here. Let's say the network that it's connected to here. Say this network. Let's go. Yeah. So this network is 192.168.1.0.24. And this one is 192.168.2.0.24. And each network has its own devices. So a packet comes from this network. So the packets go, let's say, it go, let's say it go sources of 192.168.1.1, and it got destination of 192.168.2.1. So that's coming from this network. It comes all the way to this router here. So when it gets to this router, how does this router determine where to send this packet? What does it use to determine where to send this packet? I think that's like a better way to frame the question that I wanted to ask. So what? So this packet.
Yeah,
Yeah.
you mean the routing table?
Nice one, routing table.
Yeah.
So every router has something on it, and that thing is called a routing table. So this is where we're going to be basing majority of our discussion and conversation today. So, Pameni, so what's your own opinion? So the routing table. So we said a packet has come into a router. Now the router has to determine where do I send this packet. Ferenc has said the way the router is going to determine that is going to use something called the routing table. So the next question will be, what is the routing table?
Basically, the routing table is kind of like it's, to my understanding, it's like a database that contains all the directly connected networks.
Good one. Good one.
Yes.
Contains directly connected network. Yeah, okay. So anything else? What exactly is the routing table? Basically, like on a foundational level. So you're right in that it's a database that contains directly connected, I mean directly connected networks. But what exactly like is a routing table? Or let's put it this way. If I go inside the routing table, what will I find? What are the contents that I will find inside the routing table?
Mm, you'll find all the network. You'll find the networks.
So let me bring up this one. So I found, yeah, so you're right actually. We'll find the network. What else we'll find? Parent, you can chip in. Aonika, you can also chip in. So what else would we find on the routing table? So we'll find the network. What else do we find?
So the routing protocol.
The routing protocol. Yeah, nice one. Routing
Yeah.
protocol. What else do we find on the routing table? Or inside the routing table?
Metric.
Nice one. Very nice one. Metric. So we'll discuss all this. So metric. Yeah. Then what else?
The CIDR number.
Nice
It
one.
could be either CIDR or the net mask, but it's usually CIDR.
Yep. Read the prefix. Yep. Okay. What else? What else do we find? So we have this wonderful thing called the routing table. What else do we find? So we have a network, we have a routing protocol, we have a metric. What else do we find? What about where is that network? How is it going to send it to the network that is sending it to?
Destination network.
Yeah, destination network. So that's the network at the top. So what about the next stop? So be like, I've got. So let's bring up this one. So we've got this one here, but let's try to make it larger. Um, Change settings. Let's make this one. Make it 16. Yeah, okay, this is better. So I go on this one. I go show IP route. Oh, sorry. And on this, we can see a network on here, which is what we mentioned, and this one that Frank mentioned will have our prefix or the math. We have the metric. What is this one? What is this one? This one that is highlighted. What is it?
A hop.
The next stop, exactly. So let's put that down. So we have a next stop. And then what about this one? What is this one?
Interface.
Yeah, which interface?
I think is that not the interface in which the traffic is exiting?
Good one. The interface that is existing, and then we have the protocol here. So exit. Let's go back up here. Exit interface. Yeah. So these are the content of the routing protocol. Sorry, of the routing table. The network that we're going to, the routing protocol, the metric, the next stop, the exit interface. So here's my other question is that now that's like the content of this routing table that this router has. But how does the router get information into his routing table? Because by default, if I switch on this router by default and I say, can you show me? So I have a new router that I just bought from Cisco. I switch it on and I tell the router via command, can you show me your routing table? The table that you use to send packet to this place or to that place. Can you show me what is in the routing table? What will I find in the routing table by default? Or
That's
what?
empty.
Empty. Yeah. So empty. So Ferenc says empty. So who agrees or disagrees with Ferenc that it's empty?
Well, Ferenc is the expert, so you said it yourself, right?
Nice choice,
I
Aonika. Nice
know.
choice.
Look,
Nice choice.
but I was successful in configuring my own
Yeah,
wireless router. I would still call it a router
yeah,
because it connects the network from my ISP provider
yeah,
with the network from my home, right?
yeah. It does perform exactly.
A friend of mine at work
Yeah.
said that it's not actually a router, the wireless device that I keep at home.
Well,
I'm not sure.
yeah, it does
It
perform.
says,
Well, technically, I will call it a router. Well, it may not be. It may not have like the same features as enterprise class routers, but it technically is still a router because you find that many of them still run the RIP routing protocol. So many of them still have a routing protocol that they run, like many of those little home routers and all that stuff. So it still perform a routing function. So technically speaking, it's a router. It may not have the same features as enterprise class ones like Cisco's and HP's and all that, but technically still It's the router. No.
So the interface that we see when we open a browser
Mhm.
on HTTP 192.168.0.1 or 1.1,
Yeah,
doesn't it belong to the router?
yeah, it does.
Isn't it from the firmware or something?
Yeah, so that's like a bit of a different thing because most of those ones are are programmed already by the ISP. So the ISP has programmed them to function one way. So the ISP has pre-configured them and pre-programmed them. So that's why you get the IP by default. So it's not actually there by default. So the ISP, before they sent it out to you, they've already configured it and programmed it.
Oh, I see.
Yeah, so that's why. So
And
yeah, so
that's why
yeah, carry on. Sorry,
I'm sorry.
sorry, Uncle.
Um, your ISP just brings you out a router, what they say that it's a router, but if you check it, it has usually a DHCP server,
Yeah.
graphical user interface. So that's what you can open from the browser.
Mhm.
So it has almost a DNS server function too.
Yeah.
It's not really a DNS server, but it's almost
Yeah.
it's pretty close to. So it's a pretty combined stuff.
Yeah. And some of them even like have firewalls on them and have like like you
Yeah,
said, many stuff.
firewall, five. Yeah,
Some of them, I mean, modern, some new ones even do things like file sharing and stuff like
yeah.
and do all kinds of stuff like that. Yeah. So it's like a special type of software, but one of the functions that it does routing also. And all that. So back to this one. So we said, so Ferenc said it's empty. So what do you say, Pameni? What's your opinion about it? So I bring out the router from Cisco, a newly bought router. I open it. I say, can I see your routing table? What you use to determine where you're going to send packets. So what will be on the routing table by default?
Well, by default, I presume you in the routing table you'll have to configure it not dynamic, but administratively you'll have to populate the routing table by configuring. So
So,
it,
but by
it,
default, if I
it's
switch
empty
on,
like
yeah, but if I bring
yeah.
a new router home and I switch it on, what will be in the routing table by default?
I don't think you'll find anything because nothing would be configured yet.
Yeah. So basically, you are agreeing with the expert.
Yeah.
Yeah, nice one. See, it's a nice idea. So we all agree with the expert. So by by default, it's empty by default. But here's the thing. What if I go on the router and I say to the router, okay, this interface on you, I want to configure you for IP address 192.168.1.254. And I go on this one and I say, oh, this interface, I want to configure you for 192.168.1, sorry, .2.254. So after doing this, so I configure these two interfaces on this router, what exactly will be in the routing table if I go there and I tell me what your routing table is like? What will I find there now? So what will I find there? Pameni.
Sorry, can you just repeat that again?
So I have let's bring up a router here. So
Sorry, just to don't be so confusing, just prefix because
oh, okay. Yeah. Sorry. So let's
you know what I
go.
mean.
Yeah, yeah, exactly. I agree.
Because
Yeah.
sorry.
Ah, no, I agree. I agree with you totally. Slash 24. Yeah. So we've got this. So I go on this router now, and let's say this interface is, let's just make it so that let's say this is interface F01. And let's say this interface is interface F02. And then I go on there and I say, this interface, this is your IP address, this is your prefix. I say to this
Yeah.
interface, this is your IP address and this is your prefix. And I'll go back to the router and I say, show me your routing table. What will I find on the routing table now?
You will find the two addresses of first Ethernet 1 and 2, which are directly connected to the router.
Yeah, okay. Anyone agrees or disagrees?
No.
Frank, do you think I'll find the addresses of these interfaces, or what do you think I'll find?
No.
What do you think I'll find?
Two, you're gonna find two directly connected /24 networks on it.
Nice one, nice one. So that's the key point. Remember that for many. So it's not
Huh?
gonna, so it won't just tell, you won't find just the IP addresses. You find the networks. Remember that when we talk about routers, we're talking about networks.
Networks, yeah.
Yes. So when you talk about router does not, well, there are few exceptions. Yeah. But routers doesn't really care about hosts or IP addresses. There are exceptions. There are certain things that you can do. But routers hardly care about that. Router is mainly concerned about networks. I want to move something from one network to another network. When you get to that network, the switches will handle how it gets to the devices. But as far as I'm concerned, my own is to move you from this network to the network you're going through, and then the switches will handle and do that by itself, and do the other thing of delivering it to the device that it's going to. So we'll see on there, if I go show IP route there, we'll see on there the networks that is directly connected, which brings me to another question. So the other question is this: we're talking about the routing table. There are different ways that this routing table can be populated. What are the different ways that this routing table are populated?
Mm, beats my mind.
Different ways that by which it's populated. Ferenc, what do you think? What the
Oh,
That,
sorry, could you repeat that,
so
please?
so the routing table, um by default we said it's empty, right? Then
Yeah.
over time it begins to fill up with different networks. So it begins to fill up and saying things like, if you're going to network 192.168.3.0/24, this is the
Yes.
way that I will send you. If you're going to 10.3.2.0 /16, I'll send you in this direction. So what are the different ways that the routing table gets its information from? Usually there are three ways that it gets its information from.
It's basically we have to type in.
Good one. So by you, the administrator. So as an administrator, you can tell the routing table, this is the information I want you to put in it. Yep. So which other way?
Sorry?
Which other way? Which other way does it get its information from?
Which?
Which other way, as in how else does it populate
Oh.
with the routing table?
It's gonna learn from the dynamic routing protocols or the neighboring routers.
Good one. Dynamic routing protocols, which is like, yeah, same as the neighboring routers. Any other way that it learns, that it populates the routing table? Any other way? Tamani, what do you think? So you said you can be populated by you as an administrator. That means as an administrator, you can go to the router and say, if you're going to this network, send it outside this direction. If you're going to this network, send it outside this direction. So you can do that as an administrator. Or what you can do is you can configure dynamic routing protocols, like Ferenc said, and say, I'm configuring this protocol on you, and I'm configuring this protocol on the router that's next to you. And then what this router would do is that it will say to the other router, or actually not, routers don't really communicate to one another. Routing protocols communicate with each other. Routers don't communicate with routing protocols communicate with routing protocols. So the routing protocol on this router will communicate with the routing protocol on the other router and say, you know what networks I know about? I know about network 192.168.1.0/24. I know about network 192.168.2.0/24. And then the other router will go like, thanks very much for that information. I also know some networks. Here are the networks I know about. And then they pass that information between one another. So that's the second way. So which other third way do routing tables get their information from? Which other way?
And in
From
bit.
neighbors.
In
The
bit.
neighbors. So the neighbors is dynamic routing protocols. That's the neighbors.
Yeah.
Okay.
So which other way? So it's like it is sort of like a trick question. It's something straightforward. The router itself. So the router itself can populate the routing table. What does it use? The directly connected network. So that's the router populating the routing table itself. So it's not kind of like a technical, yeah, it's kind of like a trick question. Trick question.
Yeah,
So there are three
that's
ways.
tricky.
Yeah. So there are three ways. So it's either you as an administrator tell the routing table, I want you to input this. Say they are called static routes. You say, if you're going to this network, this is the direction I want you to send it. If you're going to this network, this is the direction I want you to send it. And the routing table stores that. Or the other way is you configure your dynamic routing protocols and they talk to one another and they populate the routing table. Or the other thing is you can go to a router and say, you know what, this interface on you, it's connected to this network, and you give it an IP address, and the router automatically takes that information and populates the routing table and says, well, if I'm connected to this network, then that means that network is outside this interface. So the router takes that information and populates its routing table with that. So here is where we begin to get into some interesting discussions about the routing table. Is that okay? So let's cancel this. So we have a routing table here. So what criteria does the routing table? Because here's the thing: this router. Let's go back to this router. We said it can get information from three different ways. Now, if I go on this router and I say I want to configure you for dynamic routing protocol, we won't get into it now, but just RIP. I want to configure you for dynamic routing protocol OSPF, and I want to configure you for dynamic protocol EIGRP. And then by RIP, this router learns and says, well, I know of network 10.1.1.0 and with /24. And OSPF says, yeah, I also know of 10.1.1.0/24. And EIGRP says, well, I also know of 10.1.1.0/24. This router can only install one route for the same network in its routing table. So that's where we get into this discussion. How does the router, or what process does the router use to determine which network to install in its routing table? So it goes through a standard process. It's a standard process that it will be useful to know because it's a really useful process, especially in like future studies and all that. So the router has a standard process, routing table, standard process for installing routes into the routing table. So let's give this illustration now. So if I go back to this one and say /16, say this one is /24, you say this one is /26. So here is the router. These three routing protocols have just passed on this information to our router. So VIP is like, I know of network 10.1.1.0/16, or let's put it this way, 10.1.0/16. And this one is like, yeah, I know of OSPF is like, yeah, I know of 10.1.1.0/24. And EIGRP is like, I know of 10.1.1.0/26. So um, which of these networks and their parts will be installed into the routing table? So that's the
Okay.
first one. So which one of them will be installed inside the routing table?
Oh, RIP.
RIP, okay. So Pameni said RIP. So Pameni, you have to justify your answer. So what's the reason why you think it's RIP?
Uh, there's a rule, if I should put it, there's a rule that I really can't quite remember, whereby when the router, um, how should I put it? Like, for example, you've set RIP
Yeah,
10.1.0.0/16.
yeah,
OSPF is /24 and EIGRP is /26.
yeah.
The first lowest prefix will be the one on first on the list.
Okay. So we
And,
go, yeah, okay. Joseph,
yeah,
what's your opinion,
and,
Joseph? If you can talk. Which of these network and their parts do you think will be installed inside the routing table? So the routing table is getting like, it has all these different sources of information. Like I'm getting information from the administrator, I'm getting information from the routing protocols, I'm getting information from myself, what has been configured on me. Now I have to decide, what am I going to install inside the routing table? Because here's the way routing works, like as basics. So you have the routing process and you have the forwarding process. So a packet arrives at the router. The router has to determine, where will I send this packet? So what's going to make that determination is the forwarding process. It's like I'll be the one to decide. The routing protocols don't decide where packets go. The router decides where the packet goes. And the router makes that decision using its forwarding process. So the router has to determine, where am I going to send this packet? And to make that decision, it it goes and consults its routing table and says, routing table, what do you have for me? Do you have any routes for this network? I'm going to this destination. And which routes do you have that matches this? Now, the routing table has like all these sources that it gets information from. So it has to determine, like, okay, you'll be installed in my routing table. Sorry, I have to reject you for now. Yeah, this information, yeah, I'll put you in my routing table. Sorry, I'll have to reject this other information. So this three information has arrived. Pameni's opinion is like, the RIP one will be installed because the lowest prefix. So what's your own opinion, Joseph?
Hmm. My opinion on this probably is OSPF.
OSPF? And
Yeah.
why?
Because OSPF, right? Its basic rules is finding the shortest path possible to its destination from the receiving end, that's the source IP. So I believe that using that for building your routing table, and when the IP packet is going through, or the Ethernet packet is going through the network, and it looks at the routing tables,
Yeah.
I believe using OSPF, it wants to find the most efficient and the most shortest path possible to the destination IP address.
Okay, so we'll put that down. So we got Joseph's opinion on that. We'll leave Aronica because Aronica says he's getting introduced to this stuff. So I understand that. So, Ferenc, what do you think? Which one do you think will be installed?
So that's a pretty tricky part of this because, well, so from the advertising
Yeah,
router point of view,
yeah,
is every single network will be in the routing table, which basically set up for the routing protocol.
Yeah.
So if I say that I want to advertise 10.1.0.0/16
Mm-hmm.
as RIP routing protocol,
Mm-hmm.
I just have to write down that router RIP and then the network.
Yeah.
Then I can do the same with the OSPF and with the EIGRP.
Yeah.
From the another router's point of view on the network
Yeah.
is every single routing protocol will be on the routing table, which is advertised, and basically which routing protocol is set up on the routers. So as a network engineer, you have to sometimes you have to separate voice and data routes.
Mm-hmm.
So sometimes you have to use OSPF for the, I would say, the VoIP,
Mm-hmm.
and you have to use RIP for the data.
Mm-hmm.
So you have to advertise both of the routing protocol, both of the networks on the same router.
Mm-hmm. So,
So that's
so from this
this
one,
is
which
the
one do you think will be installed on the routing table?
yeah. So that's gonna be the area border gateway, basically from the OSPF.
OSPF. Okay.
Yeah,
So
it's an area border gateway,
OSPF.
which is basically does the routing between OSPF and EIGRP
Yeah. I've got
or RIP or whatever.
I've got a Cisco documentation that I'll post in the chat window. So that's what the things in this documentation. That's what we're discussing today. This like the the routing process. So that's what we're discussing today. So if you look in the chat window, you see a link to a Cisco documentation that I posted in the chat window. So
Hmm.
I recommend going through that the information in that link very well because it's really useful because that explains how Cisco's version of the routing process, how it makes decisions about what to install in the routing table or not. So in this situation, Ferenc is right in saying all of them will be installed in the routing table. So you go to the routing table, it will install all of these. So it will install the one learned from RIP, it will install the one learned from OSPF, it will install the one learned from AIGRP. But what if all of them were to be the same? What if this one is 10.1.1.0.0 and this one is .0.0 and this one is /16 and this one is /16? Which one will be installed in the routing table? Because it definitely will not install all of them in the routing table because you have the same path learned from different routing protocols. So the routing process has to make a decision. Which one of these will I install in the routing table? So which one do you think it will install in the routing table?
I think RIP would be installed as default.
RIP. Why?
Um, I think it's because RIP is basically, this the standard routing process with routing internet traffic through a router. Um, in my opinion, I'm not 100% sure. I'm just taking a wild shot here, but
Yeah,
I was just reading lightly.
yeah.
I could see that RIP was kind of the first one, and then went on to the other routing protocols. But I believe it's because RIP is the standard routing protocol used, and then there's also the other ones. So, but
What do you think, Pameni? Which one do you think will
sorry.
install? Pameni, what do you think? Like all of them have the same prefixes. They are the same network, the same prefixes, learned from different routing protocols. So which one do you think will be installed?
Okay. Yeah. I'm stuck.
Yeah, no problem, no problem. We'll break it down. Don't worry.
Yeah.
At least or at least we'll try to discuss it and break it down.
Yeah. I'm a bit stuck, but what Joseph said, it's RIP is a basic standard protocol, but now that they are all on the same network,
Ferenc, what do you think? Which one do you think will be installed in the routing table? So there are
That's pretty good.
3, 4, 5. So there are 5
Could be
methods that
chosen.
use it.
Could be chosen by the metric.
Mm-hmm. That you're in the right direction. I think you're really in the right direction. Could be chosen by the metric, but before the metric, if you go through that documentation again, maybe after the hangout, if we all go through that documentation, we'll learn a lot. Really good documentation. Because before the metric, it uses something. Before it goes to start using the metric. The first one I put down here, which we explained, we said uses longest prefix. So
Yeah.
after that, there's something else. The lowest administrative distance. That's what it uses. So you find that in that documentation. So three routes, sorry, three networks, three the same network from different protocols have been advertised to the same router. Now the router has to decide. I can only install one in my routing table. Which one will I install? So assuming, like we said earlier, assuming they all have different, prefixes, the router will install all of them because as far as the router is concerned, they are different networks because they have different prefixes. So the router will go, yeah, I'll put the three of you in my routing table because you have different prefixes, you are
Different
different
subnet.
networks.
Yeah.
Yeah,
Different subnets. Yeah.
yeah. But if they now happen to have the exact same prefix, that means it's the same network. So it's like I have to decide which one I want to install. Then it goes to number 2. Number 2 is lowest administrative distance. So it's like which of these ones that I've named, which of them has the lowest administrative distance? So that brings me to my next question. What is an administrative distance?
I'm not sure.
What's an administrative distance? Because that's what it uses. So what's an administrative distance? Any
The
thoughts?
cost of the route.
What?
The cost of the route.
It's close. It's not exactly the cost. The cost is like, yeah, it's close.
Yeah,
It is different.
because it's a bit different on OSPF and a bit different on EIGRP.
Yeah, it is. So administrative distance, when you think about it, about it as the trustworthiness. So the router is like, I trust you more than I trust you. So it's like Ferenc is giving me an information, Aronika is giving me an information, Joseph is giving me an information, Pamini is giving me an information, and now I have to decide which of them do I trust the most. So then I have to rank it and say, okay, I trust this information coming from this one more than the information coming from this one. So actually, let's bring up Google and let's go for. So there are default values. So if we go, let's bring up Google. Let's go for default administrative distances. Yeah, this is one from Cisco. Let's see. So let's maximize the screen. Yeah, so let's go down. So look at this. It says um, administrative distance defines the reliability of a routing protocol. So in other words, how much do I trust you? And there are standards to them. This is the standard. I was told, I'm not yet on the CCNP level, but I was told that in CCNP we basically have to know all this by heart. We have to know the
Oh
default
God.
administrative distances of all the routing protocols. So these are the default. So it's like connected route, in other words, directly connected network to the router, has a default administrative distance of 0. Static route, so I go in as an administrator and I type in IP route. If you're going to this network, send it to this place. The router gives it a default administrative distance of 1. Let's see that. So let me bring up a router now. Let's
So
bring
like a
up.
serial interface, right?
Yeah, not even a serial interface. So that is like a static route that I type in myself. So I go in and I say
Oh, okay.
conft. I go IP route. this is me supplying information to the routing table. I go IP route. I want to go to 10.5.0.0. It's like, yeah, what's the prefix mark? Let me say 255.255.0.0, say flag 16. He said forwarding router's address, or I can even just use a tunnel. Sorry, an interface. So let's say fast Ethernet 0/1. Maybe I hope there's 0/1 there, and then I can go enter. Now if I go that, yeah. So show high pivot. So this one, which is the one that I just typed in now, is it? No, that's not the one I just typed in now. High pivot 10.5.5.5. Yeah, okay. I think I know what's going on. Let's go back. Let's say 0. Yeah, there we go. Because the interface that I used, so now we have static 10.5.5.0.0 is directly connected because I've said it's outside this interface. Now, this static route that I've just typed in, it has an administrative distance of 1. So that means, and one thing with administrative distance is that the lower the administrative distance, the more trustworthy it is. So in other words, the router trusts the routes that I type in as an administrator more than it trusts internal AIGRP routes that it learns by AIGRP. So in other words, if you look at these administrative distances, you see internal AIGRP is lower than OSPF. So that means it trusts internal AIGRP than OSPF. This one is basically just ridiculous. Cisco should change this because IGRP no one uses. Really, really bad protocol, but yet it's got a lower administrative distance than OSPF. It's got 100. OSPF is 110. RIP is 120. So back to our whiteboard. So now we've got this tree. The one is going to install is EIGRP because EIGRP has an administrative distance of 90. This one has an administrative distance of 110. This one has an administrative distance of 120. So the router is like the one I will install is I'll install EIGRP. So what happens to these other two? What will happen to them?
They won't be put on the tables.
They won't be put on the table, but what will the router now do with them? Here's what the router will do with them. There are two things the router can do with them. The router can either have them to keep trying to put the root back in the routing table. And the reason for that is, let's say in case this part was to fail, if OSPF keeps trying to put his root in the routing table, so OSPF is like, I'll try again to put my root in the routing table. I'll try again. So in case this one fails, at one point it will try again and you'll be like, yeah, I can be installed in the routing table now. Or what it can do is that some routing protocols like OSPF and RIP version 2, they have their own internal database. So it can keep them in that internal database. And if the one that the router has installed, if this one fails, the router will go and tell OSPF, can I have the other route that you sent to me earlier, please?
Okay.
Because I need to install that one in my routing table now. So again, the first one it uses is prefix. Let me not put longest prefix now. Let's just say prefix is the first one that it uses to determine what do I put in my routing table. So it's got information, but if there are different prefixes, it installs all of them because the router is like your different networks. If they are the same prefix, it has to select based on administrative distance. And the lowest administrative distance wins. There are default values for administrative distance, but as an administrator, you can also configure by going, if I go router OSPF 1, and if I do a question mark, you see this command here called distance. Define an administrative distance. So let's say you as an administrator, you're like, I want OSPF to win more than here IGRP. What I can
So you
do
can
is,
modify it.
Exactly. I can put in my own value as an administrative distance. So that's where it uses. But let's now go to the next one. Now let's now say this one is OSPF. Yeah. This one is also OSPF. So obviously they now have the same they now have the same administrative distances. So OSPF maybe it's learning one route from one router, it's learning the same route from another router, and they are all coming in from the same protocol. So the router is like, okay, I've got these three routes. They all got the same um, same administrative distance. So what else does the routing process use to determine what will I install in the routing table? What's the next thing that it does? That is where Ferenc next one comes in. Metric. That's where metric comes in. So my question now is, what is a metric? So we'll go for Ferenc first. So metric. So when we say metric, what is metric?
Oh, sorry, that's me.
Sorry.
Oh, sorry, I need to wake up.
Sorry.
Oh, that. Oh. How can I put it? Wow.
So we got prefix. That's the first thing it uses. So if they're the same prefix, yeah, I will install only one of you. If they're different prefixes, yeah, I'll install all of you. But if they're like the same prefix, the same network, it's like, okay, administrative distance, the lowest one is what I'll use. But now, okay, hold on, OSPF is telling me the same network that is learning from different sources, but they've got the same network and the same prefixes. I have to determine what do I install. And this is not like a strange situation. Like let's say you've got redundancy in your network and
Yeah.
it's learning one route, the same route from two different sources, and it's like, hold on, I can only install one in my routing table.
Yeah.
So metric. So what is metric?
It's
Routing metric.
how I remember it's based on the administrative distance
Yeah, plus something.
uh, divided by the what?
Ah, okay, no, let me help with this, Frank, because it's different. Metric is different for every routing protocol. So I know where you're going with that. So I understand where you're going with that. But metric is different. I just
Okay.
want the general idea of what a metric is, because metric is different for OSPF. It's different for so they all have different
Sorry.
metrics.
EIGRP is with the bandwidth, I guess.
Yeah, so it has many. They can use many. They have different ones that they can use. So
Sorry, I just got up almost 40 hours ago, so I'm a bit.
no problem. No problem. Metric. So what is the metric? Mhm. So metric, basically to put it, Pamene, you want to try, or Joseph, or Mark? Does anyone else want to try before we go ahead to just quickly give a brief?
The lowest metric.
Yeah.
Um, I'm gonna. I don't know.
No, no problem. Sorry. All right, Pamene, you want to try? What's metric?
A measure used by the routing protocol to calculate the best path to a given destination.
Yeah, you're right. So it uses so this one is like so OSPF can say, okay, this is so the router again. Remember when we talk about administrative distance, that is in relation to the router. So the router
Okay.
is saying, I believe OSPF more than I believe RIP. I believe EIGRP more than I believe OSPF. I believe static route more than I believe um, EIGRP. So that's the router, right? So now the routing protocol itself, when it's learning like all these different networks and routes, the routing the routing protocol itself assigns um, metrics to them, or sorry, assign costs to them based on metrics. So what that means is basically the routing protocol version of saying this is more preferable than this one. So this one, we say this one is reliability and trustworthiness. That is this one. This one is, permit my English, preferability. So in other words, I prefer this one more than I prefer this part. And that is not from the router, that's from the routing protocol. In other words, RIP uses a metric. Anyone knows what the metric of RIP is? When we start discussing the routing protocol, we'll get into this. The metric of RIP, anyone knows what it is? Up count. Right? Right? That's the metric of RIP. RIP's metric is up count. In other words, let's go bring up something. Let's go paint. Let's go.
Research.
There's a router here. 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 And these are all connected. So RIP's metric is really simple. OSPF and AIGRP, they're also really simple, but they just need a bit more explanation and all that. So RIP goes, okay, if I'm router 1, and this one is router 2, and this one is router 3, RIP goes, oh, I know the path to router 3. The path to router 3 is 2. That's the cost. And that is because this router is 2 hops away from me. Because RIP's metric is up count. So RIP goes, this is 2 away from me. It's like, hey, let's say this is 6. This is 5. This is 4. It says, I know the path to router 6. It is 1, 2, 3. It is the cost is equal to 3. Because it is 3 hops away from me. Oh, sorry. Yeah, so he said, I know this one because it's 3 hops away from me. So in other words, if RIP learns from this one and is like, okay, let's say for some reason, let's say for some reason you have this one connected here, and then RIP learns from router 3, it learns from it from this way, in this direction, and it learns from it in this direction. So what RIP will do is that, well, paths to router 3, I've got it in 2 ways. To router 3. I've got 2 hops away, and I've got another one that is 1, 2, 3, 4 hops away. So that's the one situation we're talking about. So now the routing process has to determine which one of these two advertisements do I install in my routing table. It goes from
2 hops.
one exactly. Why? Because that is the one with the lowest metric. Again, remember, in this situation, because they both come from RIP, they have the exact same administrative distance. So the administrative distance for both of them will be what? What is RIP's administrative distance?
120.
120. So both of them, the administrative distance will be 120. So now it's like, okay, I've got the same administrative distance. Which one do I use? It goes to metric. And in this case, it's like this one is 2 hops away. This one is 4 hops away. So also, OSPF has a way of calculating its own metrics. It's not hop count. OSPF is different. AIGRP has a way of calculating its own metrics, its own cost, which is different. So we'll get into all that when we start talking about the routing protocol. But that's the next thing it uses. So what about, let's say, for some reason, this is not the situation. Let's say for some reason, so I'm sure that we've clarified that. Let's say for some reason, this router is this way also. So it's got this one connected here and this one connected here. So in other words, if it learns of router 3, this is 2 hops away. If it learns from me, it's from router 4. How many hops is it?
1 hop.
No, it's still 2 hops because it's got 4 and 3, right? If it learns from it from this one, it's still...
Oh, sorry, I heard the wrong number.
So you get the point. So that's the one we're discussing about now. So now we've discussed this one. So we said the next one is trustworthiness, right? Oh, sorry. Let's go down. So next one is lowest metric. So what if the metrics are the same? What if for some reason the metrics are the same? What happens? Does anyone know what happened? So in this situation, the metrics will be the same, right? So in this situation, let's say the prefix is the same. What else is the same? The AD is the next one. The administrative distance is the same. What else is that? The metric is the same. So what else can it use to determine which one to install in the routing table? Anyone wants to try? So all these things that we're discussing, I will encourage us. You see that the document that's in the chat window, I'll post it again for people that just joined. The document that's in the chat window has all this information that we're discussing. Everything in that document. Everything is in that document. So if it's not the metric, what else will it use to determine what to install? Anyone? Joseph, what do you think? So after metric, if the metric for some reason is the same, what else will you use?
I'm not sure.
No problems, no problems. No, that's why we're doing the whole discussion. It just happens
Mhm.
that because I've gone through the document earlier, that's the only reason. So it's not something to be to be ashamed of or anything. So that's the reason why we're sharing information between one another and stuff like that. I'm sure at some other points that there are things that I'll learn and stuff like that. So anyone has like any idea of the next thing that we use after metric? So if all of these are the same, the router just goes, I give up. I'll do load balancing. I'll balance the load between the two parts. So that should give you like an illustration of how, if you want to achieve load balancing, routing load balancing in your network. Let's say you've got two parts going out to ISPs, and you're like, oh, I want to make I want to make traffic go out through these two at the same time. This is one way to achieve it. So just if the advertisement is the same and the administrative distance is the same and the metric is the same, the next thing the router will say is I'll load balance them. So let me actually bring up that document that I posted in the chat window. So let's bring up this document. So you can see route selection in Cisco routers. And then if we scroll down, it now talks about building the routing table using administrative distance, which is the measure of the trustworthiness, then metrics, which is the measure used by the routing protocol, not the router, to calculate the best path. So after that, so you got prefix length, of course, and then they discuss administrative distance and all that. So where they now get to was now like, what if they are the same? What will it do? So if I go, yeah, look at this. It said the path with the lowest metric is selected as the optimal path and installed in the routing table. If there are multiple paths to the same destination with equal metrics, load balancing is done on this equal cost paths. So it just does load balancing. It just load balances them. So I hope that's clear, right? At least to an extent, right? I mean, we don't need to know the details, but at least we have an idea of the foundation of how the router installs paths inside the routing table. Is that clear, right? That's clear a bit. Yeah. Okay. So yeah. So I think that's probably where we'll stop today, because I think that's like a lot of information. And I think it's a really good place to start to say, okay, this is the basics, this is the foundation. We go study that document. Then from next week, when we start, then we'll start getting into RIP from next week. We'll do an hangout on RIP next week, where we get into RIP, configuring RIP, working with RIP, and all that. So nice hanging out with you guys today, man. so so it's nice. So, or does anyone have any questions regarding this? In case I have an answer. If I don't have an answer, I'll just direct you to Google.
I have a silly question.
Yeah, sure. Go ahead.
I'm having an 1841 router that I just picked up on one of my garbages
Yes.
during my picking up of items.
Yeah.
Just a minute.
Yeah.
Now, this router, it's the same router that you just have in the image for those who are wondering.
Yep.
You can just bring up that image.
This one. Let's go. Yeah.
Yeah, the image itself.
Oh, you mean the, okay, yeah, I get what you mean.
Right.
This one, yeah.
Yeah. Now I found myself resetting the password to the factory default. I got it successfully,
Yeah,
and there were some configurations on the router, so I had to wipe it out in order for me to use it.
yeah,
I came to a I began stuck at configuring the VLANs,
yeah.
which to me, okay, I'm a baby still in CCNA, and I'm just venturing, like
No
just started
problem.
this
We're
morning.
all babies. That's what
So
we're thinking.
my main problem is when I configure
Sorry about that.
VLAN, when
Sorry?
I start configuring the VLAN on this specific router,
Yeah,
Which kind of router are we talking about? Sorry.
the 18th, the same router that you are looking at, I think this is an 1841, or is this the 1803? Oh 06.
yeah.
But basically, my
1800
problem is
series. Yeah,
yeah, my problem is when I was configuring the VLAN,
yeah,
it felt so different than configuring VLANs on the switch, which I got totally confused because when I entered configuration mode,
yeah,
I couldn't set the VLANs, and when I entered I had to go and create a database,
yeah,
and then still couldn't find my VLANs,
yeah,
and I rebooted the router.
yeah.
I'm actually failing to understand where I went wrong.
So Ferenc can help with this. So Ferenc, what do you think? I tell you,
The,
Ferenc is a real Cisco product expert
1800
because
actually.
Ferenc's lab scares me. I think Ferenc mentioned the other day was like I got like all these Cisco routers. I'm like, whoa, it's good stuff, man.
no, that's why I asked that what kind of device are we talking about? Because if it's a multi-layer switch,
Mm,
that's a different ballgame.
yeah,
Or just how I have a 2620 XM with a switch module in it.
yeah,
Mm.
yeah,
That's a different ballgame again.
yeah,
So that's why I asked what kind of device are we talking about?
yeah,
The device that I'm looking at is a Cisco 1800 series. I think this is
yeah.
the layer
So
3.
yeah, so it's just a
Eh,
normal router. It's not a layer. It's not a multi-layer switch. I think.
No,
no,
this is a normal router,
Yeah,
I
yeah.
believe.
So when you set up a VLAN
Mhm.
on a switch, yeah, because you can't set up VLAN on a router. That is. So what's happening then?
Okay, the thing is, what I'm trying to understand is when I configured, I could not go into configuration mode to configure the VLAN. I had to go back to the privilege mode to create the database containing the VLANs and their names. But after saving this, I had to reload I actually just attempted reloading the switch and then did a show run to see if all my show run and I also did show villains, but I could not find my villains.
When you type in that end, so basically you go to the exec mode, just type in that right.
Just right.
Yeah.
Boy.
Or copy running config to startup config. It's almost the same.
here's my own thought on that.
Yeah,
My own thought on
but
that is that yeah,
if you type in right, that that should work. That has to work.
like,
You did it.
so my own thought on that. Here's my own thought on that is that Ferenc is right. So that's a different situation. So you have a router, you don't have a switch.
Yeah, I have a
So
router.
so the router that you have, you actually cannot use well, I won't say cannot, but let's just put it this way, w- without going deep. You can't use VLANs on router ports because a router
Ah,
is different from a switch. So the only reason why you were able to configure VLAN in VLAN database is for the situation that Ferenc mentioned. If you get an ether switch module, then you can plug the ether switch module inside the router or behind the router, and then you can now configure the VLAN that you've created in the VLAN database and configure the switch port on the ether switch module on it. But the router that you have by itself, you basically cannot use VLANs on it.
Yes.
So that's the
Understood.
reason. So you can't. So the simple answer is you can't use VLANs on it. So the one that you're creating, it looks as if, oh, I am able to create VLANs, and you're able to create VLANs, but the thing is you can't assign it to any port. Because here's the thing you must realize. If I go back to share my screen again, let's go
Yeah.
back to screen one, and yeah, if I go back to screen one and I go, let me look for, okay, um, let's look for router, let's look for Cisco router, and let's look for Cisco switch. So the reason why is because I know images help people to remember stuff or to, so once you can see something, it's easy. So let's go look for a good switch. Cisco switch, any good one. This one is good. Yeah, let's copy this one. Let's paste it. So here we have a switch, and let me go back to Cisco router, and if I go images and copy the same image that we used, so and copy this one, and let's go back and go paste. So you see these two devices, this router and this switch, they are different.
Yeah.
And I know that you know that they are different. I know you're probably
Yes.
thinking, yeah, of course I know that they're different. But here's what I mean by they are different. Let me let me try to break that down a bit. So let's minimize it. Let me look for the back of a router rather than the front. Okay, let's use this one. So let's go copy image. And let's go and use this one rather than the front. So these two, they are different. You see this switch port on this one, on this switch. This switch port, you can't configure an IP address on it
Yeah.
because this switch port, it's a layer 2 port. You can't go into this port and go IP address, nothing will happen. You know, you can't use that command. You can't configure an IP address on that port. Whereas this port on the router is different. It's a layer 3 port. Yeah, it's a layer 3 port. And layer 3 ports, you can configure IP addresses on it. There's only one layer 3 port inside Cisco switches, and they are virtual ports, which is the one you use for management, which is interface VLAN 1 or interface VLAN, which is the one you
What
use for
about the
management.
3550s? Or are they not? You can't
Yeah,
do that on
so
them.
those ones are different. So like you said,
3550 are the layer switches.
yeah,
Sorry.
so those ones are multi-layer, yeah. So that's why those ones are different. So if it's just
Okay.
standard layer 2 switch and standard layer 3 switch, so if you have a multi-layer switch like the one that Ferenc mentioned, so the port you can either use it for as layer 2 or layer 3. It depends on you. And the way to use it for, if you want to use it for layer 3, you have to go into the command line and type a command to say no switch port. So that way you're like, I'm not using you as layer 2, I'm using you as layer 3. So now I can configure an IP address on you. But if you just get a standard layer 2 switch, it's a layer 2 port. You can't configure IP addresses on it. And if you just get a standard layer 3 router, it's a layer 3 device. All the ports are layer 3 ports. And VLANs that we know of, VLAN is a layer 2 concept. So you assign VLANs to switch ports, not to router ports.
Okay.
So you can't assign VLANs to a router port, except like you know the one where you do trunking and you have to do encapsulation and do it in a whole different way. So that's something totally different. But to answer your question, per many, you won't be
Yeah.
able to use VLANs on it. So the only way you can use VLAN is if you get this thing called um, the one that Ferenc mentioned, the Ether switch module. Now the one that I'm mentioning now, I know it because it took me lots of months to understand it. I remember when I first went for Cisco training and the instructor was like, and I was confused. I was like, how come I can't type IP address, this one on this? I'm connected, it has ports on it. What's going on? It took me a lot of months to realize, no, this is a layer 2 port, this is a layer 3 port, they're different. Because I was like, how come? The command is IP address. Am I missing something?
Yeah.
It's just IP address command. Like, but I can't say. So you need to get an ETA switch module, which
Is
looks.
that a GBIT card?
I'm sorry. What did you say?
Is that a GBIT card? Oh no, that's not GBIT.
And
It's not GBIC, it's
BIC? Okay.
NM module, network module.
Mhm.
That is the NM for.
yeah, so yeah, it's a NM. It's like sort of like an
Yeah,
expansion
I
slot.
see it's different. I see it's different. Yeah.
Yeah. So what you can do is you buy this one and you can put it in the expansion slot at the back of the router. So this thing is a switch. So all these ports are layer 2 ports. So that is like plugging a switch inside your router. That's when you can use the one that you're trying to configure per many, the VLAN database.
Okay.
So then you can use the VLANs you've configured in the VLAN database and now assign them to this switch port that you've plugged into the back of the router. So
But
unfortunately, the answer is no. So you need to get a switch to to do the
yeah,
lab that you want to do.
and sorry, just I recommend to buy a switch and not a switch module because the functions of a switch module is limited.
Uh,
It's
How
because
about
you put the switch module into a router and not in a switch.
okay?
So basically one of these modules is around in the UK is 20 quid, and you can buy a switch for another 20 quid. So
uh,
uh,
thank you.
tell me, how would you recommend about the Catalyst 3750?
I
I'm
would go
having a
for.
friend of mine who's selling it on a very cheap price.
I've got three 2950s. I would say that these are okay for the CCNA, even for the CCNP, but or I would say either 2950 or 2960.
But not 3750.
No, no, it's not that good anymore.
2960. This one's
Yeah, with gigabit ports.
Yeah.
okay.
Yeah, I have a 2950, which is just 100 megabits. I don't know.
Okay, just some show off.
Whoa, look at that. Man, I'm scared, man. Like, I'm scared. But that's big
I've
stuff,
got
man.
three 2620 XM.
Yeah.
I've got 3640. I've got three switches and a wireless router.
Mm. Wow. So you guys, you see why I said Frank is the expert now. Because when I read about the lab on the community page, I was like, whoa, this guy is like really serious about this Cisco thing, man.
Yeah, yeah.
Yeah. So does that help you, Pameni? Does that help your question?
That helps me very much. I'm going to crack my brain tomorrow in my office again.
Yeah. Nice one. Does anyone else have any questions before we end for today?
I have one question.
Yeah.
So I'm in the process. I have a few things for a lab.
Yeah.
Now I have two 3550s, 48 ports with GBIC on it,
Mhm.
and then I have one 2950. What else should I get? Or what do I have? What I have right now, is that not a great setup? Like, what's the ideal CCNA lab?
There's no ideal basically. What you can do is three. I would say at three access layer router and access layer switch, which are on the edge of the network basically. That's it. And Yeah, that's it.
So like I should probably get a router then because the 3550 is not a true router.
Those are multi-layer switches,
Yeah.
which are more than perfect for the CCNP.
Mhm.
But on the CCNA point of view, we don't really get into multi-layer switches on CCNA.
Okay.
Yeah.
Because I was thinking of getting a
I would go
uh,
for 2621 XM. That's a pretty good edge router, and it's got two fast Ethernet ports, and you can put some network module in it.
okay. 26. Sorry, you said 2620 and Sam?
2621 XM, and those are pretty cheap.
2620. Okay.
Yeah.
Okay. Yeah. I'll have to look into that. See what the prices are here in Canada.
I guess I saw just 2 weeks ago I saw one on eBay for $20.
Oh wow,
Yeah, so
that's nothing.
yeah.
Yeah, I have 20 though. I got where I work. Someone gave me a. I don't know if you know the Catalyst 4000.
Whoa, yeah.
Yeah, it's an old device. Yeah, I got one of those
No,
things,
I'm
but
checking.
it's
Whoa,
completely
those are
useless
big
because it's
ones,
Paddle
man.
West, right?
Those are huge ones. Those are like cores. Those are like core routers.
Yeah,
Yeah.
That's
yeah, but
huge.
it runs Paddle West, right? So not it's not up to with the iOS. But yeah, that answers my question. Thank you.
Oh, and what I've done is I did upgrade the memories. I mean the flash memory of the routers. So right now I can run
Yeah.
advanced enterprise services with IPv6 and much more.
Nice one. That's nice.
Hmm.
Yeah. Yeah, so like I said, like I think I pretty much agree with like what Ferenca said. I personally I won't mind like I mean if I can as right now anyone I can take I'll take anything I can take if it's multi-layer switch I don't mind. I'll say I don't mind multi-layer switch and stuff like that. Yeah, because um you can still use like what Frank said it's like above like the CCNA level that we're studying for now that but it can still be useful for you in the future if you have opportunity to get it and stuff. Because here's one other thing.
Yeah.
I'm not sure if everybody agrees with this statement, but I find this statement to be true. A senior network admin was telling me about this that CCNA it's like good, it's like a really good foundation, but actually in the real world, in network engineering, if that's what you're going into, it's like really not much because what you're expected to know as a network engineer these days goes way above like the CCNA level stuff.
Yeah.
Hmm.
So basically, if one that's going like into network administrator and things like that, so if you need to invest in like things like the multi-layer switches and all those stuff, it's worth it because you eventually go past the CCNA very soon. Very soon you'll see that once you get like to the CCNA topic, you start feeling inadequate. Because you go to the real world and they'll be talking to you about lots of concepts that you'll be like, whoa, CCNA didn't even teach me anything about this. I didn't even know they exist. That's the kind of thing I'm facing at work. Like when like other senior network engineers and admins are talking, and I'm like, whoa, what? I quickly go to Google and quickly find out what in the world did they just say. Like David, we're looking to configure this one. Can you look at? And I'm like, oh, okay, hold on, yeah, no problems. And I go on Google. I'm like, help me, Google, help me, quickly help me, because the OCC and the training and everything that I didn't even mention like a lot of the concepts and everything. But that's what you work with in the real world. So even if you get the
Yeah. Like
multi-layer
even
switch now, very soon you'll find out that the normal switch you have to get to the multi-layer switch level and start using it and stuff.
Yeah, like even where I work in the NOC at an ISP here in Canada,
Yeah.
and with the level twos, some of the things that they talk about, or certain things they have to do with switches or the routers or in our core network
Yeah.
or backbone. You're just sitting there like, what are you saying?
Yeah.
What is that
Yeah.
term?
It's true. Yeah.
Like like for me, getting into the job I was in, Cisco, I've never, never touched. Never. I of course knew they existed, but I've never touched any of their stuff. So,
Yep.
For me, it was a whole new ball game, and reading the book, and wanting to do labs with my with the unit, it's all exciting, right? So,
Yep.
but a lot of the terms, I was like, what the heck are you guys talking about,
Yeah.
So
Yeah.
I just make tickets and then shoot it off to tier 2. So.
Yeah, exactly. Yeah. So well, basically, the moment one finishes CCNA, I mean, I was thinking before that once I get my CCNA, because I wasn't too determined, should I go straight into strict network engineering and administration, or should I go, because I'm involved in like Windows stuff and I love my Windows a lot. I love my Windows server admin stuff
Yeah.
a lot.
Me
No,
too.
I do. I
Me
love it
too.
a lot, man. I tell you, I love Windows stuff. But, but I tell you, like, but after I did like the OCCNA stuff, because I currently work as a network analyst and I just feel inadequate with the information I have from CCNA. I just feel inadequate. Like every time when they're talking about stuff, I'm like, I'm really inadequate. This has not equipped
Mhm.
me enough. So I'm really, really considering, should I go for CCMP next year? I'm really, really considering it. I'm like, should I just go straight and just go towards CCMP stuff?
I want to.
Mhm.
Yeah. It'll be good. Maybe we can study together and just study it together, do the whole thing together. Yeah, so nice guys. Any other question before we finish for today? Then we'll just wrap it up, and then next week we'll start with REAP, and then we go to OSPF, then EIGRP.
I have no more questions. I'm pretty good.
Yeah, nice. Yeah.
I don't know what
Aonika, was
anyone
that
else.
useful for you? A little.
Uh,
Don't
well,
worry. Don't worry.
I get familiar with the terminology,
Yeah, yeah. Don't worry. I mean, that'll
and
be the way
it
it is the
is
first time.
useful stuff. Yes, thank you
Yeah.
all.
No, no problems, man. So I'll see you next week, guys. Have a wonderful night.
Yeah, thanks,
Morning.
Dave.
Yeah,
Yes. See
yeah.
you
Bye bye,
next
guys.
week.
Yeah. See you.
Bye.
Bye
Yeah, see
bye.
ya. Yeah, Fenrir.